Hello dear students, let's continue with simplification of CFG. We were learning about removing epsilon productions. Let's take one more example. Now in the previous video we saw how to remove epsilon productions. Let's see one more example, example number 2. Now this grammar has been given where we are asked to remove epsilon productions. For that we will have to first of all find out nullable non-terminals. Now, how many non-terminals are there in this grammar? Spot out, there are 4 non-terminals, S, A, B, C, D. I'm sorry, 5 non-terminals, S, A, B, C, D. Now, out of this, which are nullable, which produce epsilon on the right hand side? Clearly observe, A derives epsilon. So, as far as nullable non-terminals are concerned, we got A as nullable, okay. Then observe C derives epsilon. Check this production. So C is also nullable. Is B nullable? Let's question out. Is B nullable? Now B derives two things. B either derives small b capital B or B derives small b. That means in no way B derives epsilon. We don't have any such production where B can derive epsilon. So B is not nullable. Similar explanation can be given for D. Check that D derives small d. There is no production indicating that D derives epsilon. What about S? Is S nullable non-terminal? No, because S derives AB. Agreed that A can derive epsilon. Agreed. Agreed A can derive epsilon, but B at least derives small b. So this S, if you start producing something from S derives AB. If you use this production, A can give epsilon followed by B, and B can give at least B. So S will never give an epsilon as an empty string. Similarly, if you use the production S derives CD, which is another alternate production that you can use, you know that C can give epsilon. So you can easily nullify C, but D still remains, and D will minimum give D. So S derives D. So we do not have any way by which S can derive epsilon. I hope you are understanding. S cannot derive epsilon, hence S is not nullable. Just give me some time. So we have found out which are nullable non-terminals. A comma C, these two are nullable. Okay, so let's now see how do you simplify this. Now what did we learn in the previous video is that we rewrite each production. Let's write this S derives AB first. This is the production. In this we know A is nullable. Only A is nullable here. B is not nullable. A is nullable. So we write this production with A and without A. That's it. Now what other production we have? S derives CD. Now we know C is nullable but D is not nullable. So we write this production with everything on the right hand side CD, and once we write it without C. That means C can be nullified, we say, but D cannot be nullified. D must be there on the right hand side of the production. Now how do you write this next production? A capital A derives AA. Remember A is nullable. So you write this right hand side with A and without A. Now you can easily remove this A derives epsilon. Now you are successful in removing this epsilon production. How do you write this? B derives BB. Now nothing is nullable on the right hand side. Remember B is not nullable. So you cannot write this by removing B. Anyway we have the production over here. Sorry, this right hand side is capital B. I'm so sorry. B derives small b. So all these productions will stay as they are. What about this? C derives small c, capital C. But you observe C is nullable. Yes, C is nullable as you see. So you can write this without capital C. And now you can remove this C derives epsilon. What remains is D derives small d. Just check. This is the simplified grammar. This is the simplified grammar which does not have any epsilon productions. I hope you have understood. And why do you do this? So that the derivation can be done in least steps. Derivation of a string can be done in least steps, which was explained in the earlier video. I am not going through that again. Okay, let's take one more example. A quick example of how do you remove epsilon productions. Let's say that we have a production of this form: S derives AB, then A derives AA, A derives epsilon, B derives BB, and B derives epsilon. Check this. Check this grammar. Now, first things first, we don't want this epsilon productions. We want to remove them. But for that, we will have to find out which non-terminals are nullable. Clearly, A is nullable because A derives epsilon. B is nullable because B derives epsilon. Now, the question is S nullable? Yes, you must have got it. S is nullable. S is also nullable. Start symbol is nullable because if you start your derivation with S derives AB, start symbol, you can easily replace A with epsilon using this production. And in the next step, you can replace B also with epsilon using this production. So S can derive epsilon, not directly but indirectly. Hello, when you are checking for nullable non-terminals, it is not necessary that you will directly get a production of the form that some non-terminal derives epsilon directly. You may have hidden epsilon production somewhere where everything on the right hand side derives epsilon. So ultimately capital S can derive epsilon. Of course, capital S can derive more things also. For example, if you use S derives AB, in the next step, A can give AA using this production. And in the next to next step, A can be replaced with epsilon using A derives epsilon. So we have A epsilon B. And in the next step, we can use B derives epsilon. So minimum production done is S derives small a. Of course, the grammar is going to derive, capital S is going to derive more strings, but one of the strings is epsilon, as you see. So S is nullable. What you see here is the start symbol is nullable. That triggers a very important discussion over here. Till now, the two examples that we saw, in the two examples, we had some nullable non-terminals, but start symbol was never nullable. Here, the start symbol itself is nullable. So what do you do? Just check. We will now revise our grammar. Let's write S derives AB. You know both are nullable. A and B both are nullable. Correct? If both are nullable, still you write both. Then you write the same production without A. You write same production without B. But both are nullable. Please try to understand. So you should write the same production without both. Without both means you are neither writing A nor B. So what is pending is epsilon. And that's true. S derives epsilon. We proved it. So S must derive epsilon. Correct? So I hope you got why we wrote epsilon. Because if A and B are nullable, then we write both AB. Then once we write without A, then we write without B, and then we write without both, because both are nullable, isn't it? Now, if you write without both AB, then what is left out is nothing, that is epsilon. But hello, this topic was about removing epsilon production, and look, we have S derives epsilon. You might then argue, sir, we wanted to remove S derives epsilon, but we got this S derives epsilon. Now notice, whenever start symbol, if start symbol derives epsilon, then S derives epsilon cannot be removed. Cannot be removed. I know that the topic is removing epsilon production, but one of the epsilon productions we cannot remove. Which one? Start symbol derives epsilon. That has to be there. Let's continue. We will argue on this as the topic proceeds. What about this? A derives small a capital A, but you know capital A is nullable. So you will write this without capital A. Now you can remove this A derives epsilon. What about this production? B derives small b capital B, but you know that B is nullable. So write it without B. Now you can remove B derives epsilon. So we have removed epsilon productions, but one of the epsilon productions we cannot remove, which is S derives epsilon. This will stay. This will stay. Why? Why is the question? Now note, if you say no, no, sir, we want to remove epsilon production and we will remove this also. S derives epsilon will remove. Then if you remove this, then you are changing the grammar. Then you are changing the meaning of the grammar. You tell me the smallest string derived from the original grammar G, the smallest string, just check my words, the smallest string derived from the original grammar G is LG is equal to epsilon. This is the smallest string, and then more strings are derived, but definitely our original grammar derives epsilon because S can give us epsilon straight away. Start symbol can give us empty string. Now if I remove this S derives epsilon, this production from the new grammar, then I will get new language which will not contain epsilon in the language. But do you remember the definition? Language generated by the original grammar and language generated by the new grammar should be same. Strings generated by the original grammar and strings generated by the new grammar should be same, and epsilon would be missing in the new grammar. So if the start symbol derives epsilon, we have to keep it. S derives epsilon should be kept. I hope you have understood this argument. See you in the next video with more examples. Thank you very much.